Hello, welcome back to STEM with Sid, and today I'll be going over product and quotient rules and higher order derivatives. So first, I'll start with product rule. If you have two functions, f of x, g of x, here, how about I call this u of x, or just u prime, or the derivative of u, basically. Here, let me draw my u better here. Is this just a formula? It's going to be f derivative of g plus g times the derivative of f. Then you have quotient rule. So you have a function on the top and then a function on the bottom. B prime equals, it's another formula, g derivative of f minus f times the derivative of g all over g of x squared. And we can do two examples, one of each. Let's start with 3x minus 2x squared times 5 plus 4x. If I want to differentiate this, let's call it b of x. Then, here, let me just separate this. There. If you want to do b prime of x, then you do, if you treat this as the f and treat this as the g, you have f. Here, let me fix that. Oh. F times the derivative of g, which is just 4, plus g times the derivative of f, which is just 3 minus 4x. You can multiply this out to find the full derivative, but this is the derivative. You can simplify it, but yeah, that's pretty much it. Another example, let's do c of x for quotient rule. Let's do 5x minus 2 divided by x squared plus 1. C prime equals g derivative f minus f times the derivative of g all over g squared, which is just x squared plus 1 squared. So those are the derivatives using product rule and quotient rule. And if you have something that's not in quotient rule exactly, or kind of is, but it's inconvenient to use it, you can make it easier on yourself. So let's say I have a function that's 3 minus 1 over x plus 5. Now, I could do quotient rule with this, but it would be hard with a 1 over x. I mean, it would not be too bad, but it's definitely easier if you could just, multiply x on the top and bottom. Doesn't change the function. And this gets rid of that x. So you really just get 3x minus 1 over x squared plus 5x, which is much easier to differentiate, kind of like this one, right? So, and lastly, I want to go over some trig derivatives. Now, the four main ones you got to remember after the basic ones that I taught last time are tan, secant, cotangent, and cosecant. So, the derivative of tan is just secant squared x. Derivative of secant x is just secant x tangent x. Derivative of cotangent of x is just negative cosecant squared x. And the derivative of cosecant x is negative cosecant cotangent x. Now, you can also go backwards with the integration. We're not going to talk about that right now. That'll be when we get to integration, which is later in calculus. But right now, tan, secant, cotangent, cosecant. If you have a product rule or quotient rule, and this is one of your functions there, you just got to apply this rule. You have to use different rules when you have like different things inside. However, for now, if you have exactly what's here, then you can definitely apply the rule. And lastly, I want to go over first, second, and third. So higher order derivatives, basically. So there are different like ways to show higher order derivatives. But if you have like f of x, you can take the derivative once into f prime, then you can do f double prime, then you can do f triple prime for a triple derivative, and then it starts to the point where you can just write the number on the top. So like f7 is the seventh derivative, right? f4x is the fourth derivative. And another thing, another way to do it is you see my d over dx. So you have d over dx. You can, or not there, sorry. Fix that. Okay, yeah. So you have d over dx, d2x over d, sorry, d2 over dx, d3 over dx, and then d4 over dx. But yeah, that's pretty much it. And oh wait, one more thing. It's actually d over d2 over dx squared, d3 over dx cubed, d4 over dx to the fourth. So yeah, thank you for watching STEM with Sid. I'll see you in another video. Thank you for watching.